So compound interest, which is a topic that we did not get to in class, this is a subset of the exponential functions unit. Here is the formula for compound interest. You might recognize it as a equals p times 1 plus r raised to the t. This was the formula for exponential growth. Now the way money grows, also exponentially, is going to have a slight wrinkle to it. So let's go over it. Right, so we see a similar looking formula here, except for being raised to the t power, it's being raised to the n times t. And in the parentheses here, instead of r, this interest rate, it's straight up, it's divided by this same number, which we'll call n. Right, so A stands for the accumulated value, just like before. P stands for the principal, just like before. And R stands for the growth rate or the interest rate, just like before. Remember, R is going to be given as a percentage, but we have to input it as a decimal. And T is the time, usually given in years. Just make sure it matches the time frame for R. If R is given as an annual interest rate, then T must be given in years also, for instance. So our new variable, n, is going to be listed here based on words that you're going to see in the word problem itself, right? So now when the interest rate is given, it might be, for instance, 5%, and it will be followed by the words compounded, maybe compounded annually, right? But now with compound interest, the interest rate again will be given with the same number as a percentage, with a number as a percentage, and followed by these words compounded, and then one of these words here, annually, semi-annually, quarterly, monthly, daily, weekly is also a possibility. Something that we won't see, I think, in this unit, but maybe in another unit you might see something compounded continuously. Right? In this case, this is a new formula, so we will not get into that. But if something is compounded annually, that means it's compounded once a year. So that means n is equal to the number of compounds per year. That's the number of times the interest is calculated. So if it's annual, that means it's once per year, so n is equal to 1. Semi-annually, that means it's twice per year, n is equal to 2. Quarterly means every 3 months, n would be equal to 4. Monthly, since there are 12 months in a year, the interest is calculated 12 times per year. Daily, with 365 days in a year, now this is 365 n. And weekly would mean n is equal to 52 because there are 52 weeks in a year. So let's get to a problem here. Suppose an investor deposits $17,000 into a savings account. Time frame is for 6 years, and the interest rate given is 4.75%. So now we have a bunch of different scenarios. Compounded annually, the investment is worth blank after 6 years, right? So compounded annually, compounded quarterly, monthly, weekly, daily. They're giving us a bunch of different scenarios with different compounds. Let's start with number 1. Annually, we have a principal of $17,000 multiplied times 1 plus an interest rate of 0.0475, right? That is 4.75 divided by 100 to get our decimal value, a growth rate of 0.0475. This is going to be divided by 1 because we are working on the first one where n is equal to 1. And this is going to be raised to a value of 6 times 1. I'll put that like this in parentheses right there. So if we put this all together, that's going to be 17,000 times 1.475 raised to the 6th power. And here we're going to get an answer of $22,458.11. Pretty straightforward, but again, this should be familiar as just this standard exponential growth rate. When n is equal to 1, that's the standard exponential formula, exponential growth formula. So let's take a look at quarterly. $17,000 is the principal. 1 plus 0.0475. Quarterly again means that n is equal to 4, so that means this is divided by 4. And this is raised to a power of 6, because of 6 years, times the number of compounds per year, which is 4. So essentially what we are doing here is taking these 6 years and splitting it into 24 time periods, right? And because the annual interest rate is 4.75%, we have to split that into 4 time periods per year. That's the way this formula works. So we're going to get 17,000 here. I'll do it in some pieces. 0.0475 divided by 4 is equivalent to 1 plus, so 1.011875, right? So I divided this and then added it to 1 to get this number over here. That in the middle is an 8. And this is raised to the power of 24, right? That's 6 times 4. So we could put this into your calculator, and you're going to get an answer here of $22,568.03, rounded to the nearest cent, rounded to the nearest hundredth. So slightly more than what we saw for compounded annually, which makes sense because since the interest is being calculated more, that means there's more opportunity for this money to grow, right? There's more opportunity because it's now, instead of it growing once per year, it's growing 4 times per year. And that's basically how compound interest works. The more times you are compounding, the better, right? So let's write out the formula for monthly. Monthly means n is equal to 12. 17,000, our principal. 1 plus 0.0475 divided by 12, raised to the 6 times 12. Now sometimes when it gets too small, taking this decimal number 0.0475, dividing by 12 or divided by 365, then it might be worth it just to find a way to put this into your calculator, right? If you have the Calculator Plus or the TI-84 or TI-30 X2S, you could use parentheses in order to input this into your calculator, like so. 17,000, 1 plus 0.0475 divided by 12, right? If you have Calculator Plus, it uses the division symbol. If you have a TI calculator, it's going to use the slash. And then you can close the parentheses here. So in here, we're kind of just confirming that the calculator is going to do the division first. Then it's going to add up in here, and that's what the parentheses is. And this is going to be raised to, right? You can put a caret there, raised to, and the important parentheses are here, 6 times 12. Right? Because now we're telling the calculator to perform all these operations here, perform this operation here, so that we could raise this to the 72nd power, right? Without the parentheses here, it's going to perform this correctly. It's going to raise this to the 6th power and then multiply it by 17,000 and then multiply it by 12. We don't want that to happen. We want this to be raised to the excuse me, the power of 72, right? And that is going to make a difference. So the parentheses there are necessary. And whatever scientific calculator you have should be able to handle this. $22,593.24. Let's move on to weekly. Going to run out of space here a little bit. 17,000. Oh, ran into something. 17,000. Weekly means that n is equal to 52. 1 plus 0.0475 divided by 52 raised to the power of 6 times 52. Right? Once again, find out which calculator you're using and put it into the calculator like so, essentially replacing 12 with 52 in both of those cases. And your answer should be $22,603.01, right? So again, as we see n creeping up, n equals 1, n equals 4, n equals 12, n equals 52, and n is going to equal 365. Right, so, between compounding monthly and weekly, we're compounding a whole lot more. It's a difference of about, I don't know, looks like $10, right? It doesn't seem like a lot, but definitely more than the 22,458 over here. Right, so let's look at n equals 365. Again, same formula. We're looking at daily now. And since there are 365 days in a year, that means this money is getting compounded 365 times per year. This is how a bank performs its compounding, by the way. It will input it monthly, but it actually calculates the interest on a daily basis. So 365 is our n. And we're going to get here 22,605. Oh, for web work, don't put in those commas. 22,605.54 rounded to the nearest cent. So I hope this helps you with the compound interest homework. Thank you for watching. Bye.